So you can from the user string, what is that? State, yes. And then okay, you want country. Scan sc is equal to new scanner system.in. Imported control shift O java.util.scanner. Enter country. What is that? Is equal to sc dot next. So rather than passing this, you can fix it as state. Right click, run as Java application. So anyway, like it will persist because again I have removed that information from the Hibernate config file, I guess. 1 to 1. This I have removed. So you need to keep this. So it is persisted. So select tab and this time. For person we did not enter the value, but for this address we have entered this. Something DDDDDSDS. Clear? Does this answer your question?
Yes, Atika. Thank you.
Okay, welcome. Same, okay, you have to do it for person and like whenever you want to prompt from the values and pass it as an argument.
Okay.
Okay, fine. Thank you. So next is like named queries. So named queries is you can write the queries and the XML file, and then later on you can retrieve it and your what do you say, and your class files. So in order to get the instance of the name query, okay, you'll be using the method get named query, and over here if you're writing query name, find item by description, and then the query value. See data from item where item dot description like colon description. So in our case, and the departments dot this one, okay, you will be writing in the Hibernate mapping file. Now let us do this.
Atika,
Hmm.
what is C data? I mean, is it kind of a query default name or something?
The C data, okay, it is a syntax. Basically, it comes in DTD document type definition.
Okay. So it's like
Yes,
default, uh, default syntax you are saying.
yes, it is a syntax for writing the query C data.
Okay. Thank you.
So this one we will be referring. Sorry, this one is persons table, I guess. Okay, let me change it from person. So person P, where P dot. So what do we have over here for person? Where P dot F name we will take. Now if you see over here, our table name is person file, whereas our class name is person. So as we said, whenever you're using Hibernate, you'll be you'll be writing queries on objects, on associations, not on table. If you're writing the query in the pure SQL form or in the native SQL form, you should write person 5. But as we said, we are using HQL, Hibernate Query Language, where we'll be performing operations on the objects. So that is the reason again you are writing person, not person 5. So where p dot f name this is Asha. And you don't know this f name. Public static void named query. All these queries are similar to that of the SQL syntax, but there is some slight difference. So let me just copy this stuff. Okay, fine. Now if you go through this, person is our class name. Person is our class name, but in the table we have created the object by name person 5. Over here we have created the object by name person 5. This one, person 5. When we are writing the queries in the SQL, you will write the query with respect to the table. Select star from person 5. But when you are writing the queries in the Hibernate, you will be writing the queries on objects, not on the tables. Not literally, you'll not write the queries for the table. You'll write the queries for the object. So that is the reason when we are writing this from, you're writing it as person. We are not writing it as person 5. Okay. Okay. Okay, where are we? What to so then next you need to create an instance of the query. So get named query, find person by name. Set string. You don't know, let me check it what we have. John. So from this, okay, you should select this org.hibernate.query because you are using Hibernate. And then as usual, q.list. Sorry, list of persons. Press Control Shift O. Anyway, like all person P P dot get person ID. Let us call this named query not known. Find person by name. think I did not save this file. Okay. Okay, oh yeah, if you see it is printing it, 101 John and then Johnny. I think it wasn't saved. So similarly, you give like whatever queries you want, you can give the name and you can access them. Then next what you have, binding parameters. So as usual, binding parameters at a equivalent to what we have three-page statement. You've got name per parameter and then the positional. You're creating a query from item with description like search string. So this query you're passing it as an argument, and then again you are substituting this search string. This one is the name parameter. That is, to this parameter you're giving the name search string and like by whatever value you want to search. Over here, where is the query? Over here, see, we have written over here binding parameter. Select star from employees where employee ID is equal to question mark. We don't know that. Your query dot set integer emp id of 100. And we are using unique result you have to eliminate duplicates. And this one is the positional notation 1, 2, 3. Each question mark, like as we have it in what is that three-page statement. So question mark 1, question mark 2, question mark 3. So that is called as positional notation. And this question marks, it starts from 0. It starts from 0 over here. And JDBC it starts from 1, but over here it starts from 0. So we have already. Okay, I don't want to drop the tables and create the values again. So public static void binding parameters. String SQL is equal to from person. If I'm writing it this way also, it is not going to execute. From person where p dot f name is equal to f name. So this is your SQL. Pass this as an argument. Session dot create query. This is regular way. Now over here this is not going to work because over here your class name is different and the way you have written is different. So this is not going to work because everything you have written it in capital case. So let me call this binding parameters. Oh, your person is not mapped. So again it is case sensitive. It should have the same name as that of the class. So this is PS person. One not one John John. And let us see. Then positional parameters, you can just replace that with 1 2. This is like 0 1 2. Copying it. So binding parameters, positional parameter. So for this you will give it as question marks, and this question marks it starts from 0. So over here if you see, Hibernate will also let you set the entity values also directly. You can set the entity, which means you can query by object, public static void find by address. So first let us see what address we have. Let me just copy it from here because we are having this address only. So what are those values? Select star from address 5. City is null. DF. Update. I'm updating this. Update address 5. Set city is equal to. a dot set city, set state, and then again you've got country. Now you will be creating a query from person P. So what do we have over here for person? For P dot address. So P dot address is equal to address. So over here from P dot person where P dot address. So far you have been matching it to set string, set date, etc. Now you will match this to the entity. You will match this to this object, to this address object. So where dot set entity address to A. So a list of persons who will match to those will match to the address specified. So I like, because this is one-to-one relationship, we'll get only one unique result. So you can use this q dot unique result, and then this you can map it to the person P. Because it is returning an object, you have to typecast this to person, and then print it. System.out.println P dot get person ID, whatever you want, you can put that key dot get f name, l name. So is this clear? Find by address. Okay. See over here, it has returned you the entity 101 and then join. What is this? Okay, fine. Binding, we have already completed this. Binding parameters. And then ordering the query results from user u, order by u dot username, and order by u dot username ascending or descending. You want to specify whatever you want, and as well as you can go ahead with the criteria API. Session dot create criteria, user dot class, that is you want to query this, and then dot add order dot ascending, specify the column by which you want to sort. Now association we have. So this I'm not doing it again, you can do this easily. Now association, the Hibernate query, it supports performing queries on association. So join can be used to combine data into a more relation, and the Hibernate provides the four ways of performing the join operation: an ordinary join clause, fetch, implicit, and then t-touch join in the where clause. So first we'll start with this ordinary join. Now fetch join can be used to specify that an association should be eagerly fetched. Now what do we mean by this eagerly fetched association is? let's say we are having one-to-many relationship. So what happens over here is this is one object and this will like so. Now this is what happens. This is one-to-many relationship. Now let's say this is one object that is person. Let's say this is one object that is person, and this person is having some three addresses. Temporary, let's say, and let's say this is the permanent address, and let's say this is work address. So if you are permanent, temporary, and then the work address. So let's say this is what we have, and then this person is also having three addresses: temporary address, and this is the permanent address, and this is the work address. So you can say it is the collection of collections. Point number one, when it is retrieving this persons, so over here we are keeping it as two persons. This is person one and then person two, and you may have one more candidate. So let's say okay, you might have one more person, and this person again might have three addresses. So this is one collection. So this is what Hibernate does. So this is one collection, and this is collection of collections. Now for this persons, again you have got one set of collection, and for this you've got another set, and then okay for this another set of collection. Now over here you have got two options, one is eager fetch and then the another one is lazy fetch. So eager fetch means when you are retrieving this collection object, along with that it should retrieve its associated collection. That is okay, it should retrieve the temporary address, permanent address as well as the work address. Three it should retrieve. For this also it should retrieve this. For this also it should retrieve this. This is what is called as eager collection. That is when you are retrieving the person object, along with that it should retrieve all its associated collections. This is called as eager fetch. Now whereas in the lazy fetch or in the lazy association, what happens is, let's say okay, here also you have got three persons object. Now this is one collection, and it is not going to retrieve all its associated collections. In the lazy fetch, it will not retrieve its associated collection. It is going to create a proxy object. Proxy object for what is that? proxy object for address. It is not going to create it. It is just going to create a proxy object, proxy for address, and then again it's going to create the proxy for address. So this is the collection you have, and then it is associated with the proxy object. This is in the lazy fetch. It is not going to retrieve the collections. Now when it is going to retrieve the collection is when you will do person.getAddress. When you call person.getAddress, at that point of time, this will make a call to retrieve this objects. So when you make a call person.getAddress, then at that point it will retrieve that. Until then, it will not retrieve it. So when you're making a call p.getAddress from here, then it will create this stuff. Until then, if you're making a call on this person, let's say you've got 3 persons. So if you're making a call onto this p1 dot get address, then only it is going to retrieve. You did not make the call p2 dot get address. We did not make the call p2 dot get address, so it is not going to retrieve the collection associated with this p3. Clear with this? Any doubt in this? Is it clear? Eager fetch and then the lazy fetch. Eager is at that point itself, it will retrieve the associated collection, whereas in the lazy fetch, it is not going to retrieve the collections associated with it unless and until you give the call. When you give the call p.getAddress at that time, it is going to retrieve the collections of the addresses. Otherwise, it is going to replace that with the proxy object. So this is your proxy object. Is the difference clear between proxy and eager? So over here, if you're specifying fetch from item join fetch, if you're specifying fetch, then it means it is an eager. If you're specifying fetch over here, then it means it is an eager collection. If you don't specify fetch, then it is a lazy collection. That's it. So internally, that is the difference. And over here also, you can specify fetch mode.eager. So now let us do this. Fetch item.gets. Public static void fetch. What is that? Fetch person and the address. String SQL. Select from person P, fetch join address A, and you can specify where, what is that, P dot F name is equal to join. The rest of the stuff let us copy. Fetch person address. Now it is going you to return an object of person and then the address. It is going to return you the object of person as well as address. So this is not going to work. Right click, run as Java application. Sorry. So it is join fetch. So P dot address. Yeah, dot address. I think I did not save. And then okay, you can do it with the help of the an alias can be made to make the query less verbose. So you can add the alias join fetch item.bits.bed where item.description and bit amount. So over here it has retrieved this. And the same thing, okay, you can do it for this. You can you are getting the data from the, like you are querying it based on item object as well as you can querying it on the build object, both. So like in city, you can specify it as AAA. Oh yes, you're specifying item.bid, bid data amount is greater than 100. Similarly, you can fetch it from the other table also. And what is that? P.address as A and A dot city is equal to, what is that? City AA. That is okay. You can search it from both the tables as we do it in joins. Now HPL supports multi-part property expressions for two purposes. You can even query the components. Okay, fine. Now over here from person P, you are joining the table with P.address. That is okay. You are joining person and then the address table and then you are querying it. So rather than joining it, what you can do is you can directly query it from the person's table, like user u, where u dot address dot city. So this is called as implicit join, and this is supported only in Hibernate from set from person P, where p dot address dot city. So internally it will perform the implicit join. It will join the person with the address table. This time, instead of joining two tables and retrieving the data, you're joining. So this, you are performing the join operation on the component. So this you have person p dot address you're doing. Over here we have got the person table. So what are we doing is person dot this address. From this you are looking for the city component is equal to A. So this is called as querying on the components, querying on components, and internally Hibernate will perform implicit join. That is, it is going to join person and then the address table internally. So this is called as querying on components. Querying the components. And implicit joins are directed only on many-to-one and one-to-one association, and it is only available in the Hibernate query language. Any questions on this implicit join? Is it clear? Okay, thank you. Then theta style join, it is equivalent to your Cartesian product. So user, comma category, where user.username is equal to category dot created. Okay, thanks everyone. So in the theta style join, it will perform the joins between two unassociated classes. Like you will not have any association between two classes. This way how you do. So select start from person 5. I don't know whether we have this table or not. That is whichever table you want to do, you can connect it up. I think we don't have that table. So you will just, like, between two unrelated classes, you can perform, you can join them. That is called as theta type join, that is Cartesian product from user comma category. When you are executing this, it will return you two objects. It will return an object with two elements. Object 0 will have all the data related to user, whereas the second object will have the data related to the category. This is one and this one is the another. Generally, okay, we don't go with the theta style join. Public static. Theta. Now this is going to return you a list of objects. This is going to return you an array of objects. Integer I is equal to 0, I is less than O dot length, and then I plus plus. System.out.println O of I So over here, if you see, it is returning you two objects. One is person object and the other one is address object. Now in order to get this, in order to print this, check if you need to typecast this. If O of I, if it is an instance of person, then typecast it to person. Or else check whether it is an instance of address. typecast this to address. And then you can try to print it. P dot get F name. Similarly, you can print it for address as well. A dot get city. You can print all the values. So this is Cartesian project, not very useful. This is person objects, this is address object. Two objects it is returning. Object 0 is user, object 1 is category. And then again you can perform all the aggregation function. It will support average, sum, minimum, maximum, count of star. So count of star, sum of amount from bed. So you can do this. Grouping also you can do, like it has got same syntax as that of the regular SQL language. Select u dot last name, count of u from user u, you are grouping them by the last name. That is how many people have the same last name. And grouping can be restricted by using the having clause. Group by last name, having user dot last name like A. You are selecting only those user who are having A in that last name. And you can even go ahead with the subqueries. And you can, if you want to write a query that is not supported by the Hibernate, then you can go with the native SQL queries. So in order to write the native SQL queries, you will be writing SQL can be, what is that? Native query, what is native query? You'll have, okay, query dot create native query, you'll have it. Oh yeah, that didn't give, so. So SQL queries can be used to return a list of scalars. So over here you have written an SQL query, select star from app user. Now from this, okay, what you want is you want to return only the username and then the name object. So this will return the scalar values as list of objects. So for username it is one object and for the name it is the another object. Hibernate also allow you to obtain entity instances using SQL queries. Select star from address, create SQL query dot add entity. That is, it should execute this query and it should return you as an instance of this address class. Star notation will return the association. So star notation will return you the complete association. Association simple, it means join. Stored procedure is also there. Okay. This rest of the part, okay, we'll continue it tomorrow. Just try to practice this. It is easy. Slight difference is there compared to SQL. So do we have any questions for today?